Humor is a key part of our everyday. It has been shown to benefit our psychological, interpersonal, and physical connections. Humor can play an important role in improving human-robot and human-computer interactions as well. Humor can increase robot likability, ease interaction, and improve sociality. It can also bring about a positive perception of embodied conversational agents. Non-humanoid robots are being deployed to our daily lives, increasingly being used for tasks in our health centers, our schools, our workplaces. The need to be able to interact and communicate with them is key. In our study, we tested whether a non-humanoid robot that does not mimic human behaviors could communicate a humorous experience through simple gestures alone. No jokes, no facial expressions, no comical sounds. We designed non-verbal, humorous, and non-humorous gestures using principles that take inspiration from clowning, animation, and humor theory conventions. We then set up an experiment to evaluate how people respond to these gestures. In our evaluation study, we told participants that we were testing how people perform a task on a computer in the presence of a robotic object. The humorous and non-humorous gestures were performed in a random order and counterbalanced. We used a within participants experimental design, and all participants experienced all humorous and non-humorous gestures. After every gesture, we asked the participant what they thought of the robot's movements, what they liked about the gestures, and what they didn't like. We evaluated their responses to each of the gestures and their overall perception of the robot. Our findings showed that participants described 2 out of 3 humorous gestures as humorous and cited positive emotions like joy, happiness, and fun. The 3rd humorous gesture got mixed reviews. A minority of participants perceived the humorous gestures as unsettling or said they thought there was a malfunction. This finding echoes previous studies that there is a thin line between surprising someone to enjoy an unexpected situation and surprising someone into a response of fight or flight. Participants said the non-humorous gestures were calm and temperate and did not associate them with humor. Overall, our study supports that robots can perform humor that does not mimic human behavior to create a humorous experience. The slight variance in participant responses reaffirms the possibilities and challenges associated with balancing design principles for designing non-verbal humorous gestures for non-humanoid robotic objects.